Okay, this video is going to have us take a look at stoichiometry, which sounds like a really scary word, but I promise you it's not really too much more than we've already talked about. So first, what is stoichiometry? The dictionary defines stoichiometry as the relationship between relative quantities of substances taking part in a reaction or forming a compound. What that means in real words, is the ability to use unit conversions and a balanced chemical equation to calculate the amounts of reactants and products. So previously, we looked at how we could convert between moles of one substance and moles of another substance. Now, stoichiometry really just adds in another level using what we already learned about the mole, and that is that it's equal to the molar mass and equal to 6.02 times 10 to the 23rd particles or molecules or atoms. So we're going to use these mole ratios and molar mass, two things that we've already learned about. It's a multi-step process, starting with balancing the chemical equation. Now, this should not be new. We'll continue practicing it. We'll keep going with that. Then we need to identify our starting amount. That's usually given to you in the problem. We need to identify what unit we're trying to get to, again, given to you in the problem. Then we set up our dimensional analysis and solve the equation. Okay, so really nothing new. Dimensional analysis we've already talked about. Unit we're trying to get to is in the problem. Starting amounts in the problem. Balancing the chemical equation we've already talked about. So let's look at an example. So this one says potassium chloride reacts with sodium sulfate to form potassium sulfate and sodium chloride. If we use 25.39 grams of potassium chloride, how many grams of sodium sulfate do we need? So let's start by setting up our balanced chemical equation. So I crisscrossed my charges here. I had K, and I ended up with KCl, potassium chloride, plus Na2SO4, that's sodium sulfate, and it makes K2SO4, which is potassium sulfate, plus NaCl, sodium chloride. Okay, I got to go ahead and balance that. I get a 2 in front of the KCl, 2 in front of the NaCl, and then I'm going to identify my starting amount. Now, that's given to me in the problem, 25.39 grams of KCl. Okay, the of what is really important because we're going to be going from one compound to a different compound. We want to get to grams of Na2SO4. That's, again, given to us in the problem. How many grams of sodium sulfate do we need? Then we want to look at what do we know. Okay, we can calculate the molar mass of KCl by adding the mass of K and the mass of Cl together to get 74.55 grams per mole. Notice that's an equivalency. How many grams is equal to 1 mole of KCl? Then we can calculate the molar mass of Na2SO4. 2 times 22.99 plus 32.07, that's the Na and the S, plus 4 times 16, that's the O's, and we get 142.05 grams per mole. Again, an equivalency. 142.05 grams of Na2SO4 is equal to 1 mole of Na2SO4. Then we need the mole ratio between our two things, so between Na2SO4 and KCl. And our ratio is that we have, for every 2 moles of KCl, we need 1 mole of Na2SO4. Okay, and we got those numbers from the coefficients up here, 2 KCl, 1 Na2SO4. Once we've identified what we need, where we're starting, where we're going, and we've balanced our reaction, we can set up our dimensional analysis. So we put our starting number in the top. Remember, dimensional analysis, we need whatever number or whatever unit is on top, we need that same unit in the bottom of the next thing. So I'm going to use my molar mass of KCl, put the mass on the bottom, it's equal to 1 mole of KCl on the top. That means that my grams of KCl can cancel out and I'm left with moles of KCl. Now that's not where I want to end. I want to get to grams of Na2SO4. So now I need to use my mole ratio to go from moles of KCl to moles of Na2SO4. What that means is I need to put the moles of KCl on the bottom. So I put 2 moles of KCl on the bottom, 1 mole of Na2SO4 on the top, because remember those two things are equal to one another according to my chemical reaction. That cancels out the moles of KCl. Now I'm left with moles of Na2SO4, and I can use the molar mass to get to grams. So again, I'm going to put the 1 mole of Na2SO4 on the bottom. the molar mass of Na2SO4 in grams on top. That cancels out my moles. And I am ready to do my math. So when I do longer problems like these, the easiest way to do this is multiply across the top, multiply across the bottom in one big fraction, and then divide at the end. So I've put all my top numbers multiplied together, all my bottom numbers multiplied together. That gives me 3,606.6495 divided by 149.1. And when I do that math, I get 24.19 grams of Na2SO4. Notice that my units there are the units that I didn't cancel up above. Okay, now in the last activity, you ended up making a road map like this, looking at what are your starting numbers, your A, and how do you get to your B. Okay, so this roadmap, how we'd use it is we'd identify, am I starting in atoms or molecules, moles, or mass of my A, of my starting thing. Okay, depending on where you start, that's going to tell you what steps to take. Okay, you follow the arrows. Once you get to moles of A, in whichever way you needed to, you then can get to moles of B using your mole ratio with the moles of B on top, moles of A on bottom. Now, obviously, to do that step, you need the balanced chemical equation. Once you're in moles of B, sometimes I might have you stop there, but if you need to go on to atoms or molecules, you go this way. If you need to go on to grams, you're going to go this way, and you'd use this equation. So you identify where you start, identify where you're ending, and then follow the arrows, okay? The number of arrows that you go through is the number of fractions or steps you should take in your dimensional analysis. Now, you will get a copy of this or something that looks very similar to this on any test or quiz going forward to use. So if you get really good at doing this by using this little tool, you will be golden for those tests and quizzes. Now, before you're done with this one, make sure you do any practice problems that might be in your note set, and then check your work with your teacher and move on to the choice activities.